This conference will now be recorded.
Okay, guys, good morning. Welcome back to the session. In today's session, we're going to talk about something called downcasting. So yesterday we discussed about upcasting. Today we're going to talk about something called downcasting. Clear? So in non-primitive casting, in case of non-primitive casting, we have two types. Right? What are the two types? The first one is called upcasting. The second one is called downcasting. Downcasting. Okay. So for upcasting and downcasting to work, the extremely fundamental concept is we need inheritance. Without inheritance, right, this is subclass which is extending a superclass that is extending another superclass, or this may have two subclasses, right? This is called inheritance. So without this inheritance, right, this is called inheritance hierarchy. Without inheritance, we cannot achieve upcasting and nor downcasting. Are you clear? This is one primary fundamental concept, and inheritance is applicable for classes, right? So, and in future, we're going to understand something called uh, interface and abstract class. So this inheritance is applicable for this class. There is something called abstract class, which we are going to see in future, abstract class, and also there is something called interface. So you can achieve upcasting, downcasting, okay, with these three things: class, abstract class, and interface. And in today's session, or in this session, mostly we are talking only about this upcasting and downcasting with respect to the class, because we have not started learning what is the meaning of this abstract class and interface. So once we look into this abstract class and interface in future, we're going to talk about these two. But in today's session, we are restricting ourselves to discuss upcasting and downcasting with respect to only class. That too, in our previous session, I already taught you what is upcasting. The reference is from superclass and the object is from subclass, that's called upcasting. So in today's session, let's start with understanding of what is the meaning of downcasting. Again, I repeat, I have not taught you what are the uses of upcasting and what are the uses of downcasting. Are you clear? We are just in the process of learning what it is. We have not even started learning how it works, where it is useful. Clear? Remember this. Let's start with something called downcasting. Before that, let me give you an illustration of primitive data type. There is something called narrowing. Let me just give you one example of narrowing. Through that example of narrowing, I will explain you downcasting. Okay. So, for example, I have something called integer variable and I equal to 20, or let me give my favorite number, 33. Okay, let's say integer I equal to 33. What do you mean by this? So integer is a variable, or I is a variable, sorry. I is a variable. I data type is, of course, integer. Since it is integer, the capacity is 4 bytes. The capacity is 4 bytes, okay? But the data stored here is just 33. 33 is the data. All right. So now what do I do? I'm going to assign this into another variable called short or byte. Not even short. Let's take the example of byte. So I just say byte b equal to I. So this beautifully gives you an error. We call it as compilation error. because we know the fundamentals that the right side data type must be same as the left side data type, or left side data type should be bigger than right side data type. Okay, in this case the data type of I is integer, and in this case the data type of B is byte. Okay, so, and unfortunately B is, that is byte, is smaller than integer, right? Byte is having only smaller capacity, right? This is B data type is byte. The capacity of byte is only 1 bytes, not 1 bytes, 1 byte. All right. So whenever you try to assign it, this cannot store. Basically, byte can store 33, but compilation error, because left side is smaller than the right side. So that's why, to overcome this situation, what you're supposed to do is you have to write the logic like this. The proper logic is this: byte b equal to, sorry, I use this, byte b equal to, okay, byte b equal to byte of I. Now, if you carefully observe, the data type of I is integer, and here the data type of B is byte. Byte is smaller, but right side, what is int? What is there in the right side? Integer, which is bigger, nothing but 4 bytes. This is only 1 byte. So since it works from right to left, right side is bigger one, left side is smaller one. That's why we call this concept as narrowing. Uh-oh, sorry. This is called narrowing. So I'm going to pause here for just 10 seconds, go through this. This is called narrowing, bringing down from higher data type to lower data type, but never forget we are applying here the casting, right? I'm applying the casting here. Now we will try to understand this concept through non-primitive data type. That's called downcasting. I'm going to scroll it down. Okay, thank you. Now focus. I'll take some vague, simple examples, okay? Let me write some inheritance hierarchy over here. Let's imagine, oh, what is happening here? Okay, I write one superclass and I write one subclass. I'll take certain easy examples, okay? The superclass is called dosa. Subclass is called masala dosa. How is the example? Okay, this is a data type, and this superclass is a bigger data type, correct? The bigger type, this is called smaller type. But ultimately, they all are data type. Now, what do I do? Sir, I'm going to create an object, okay? Object of masala dosa. Concentrate, don't deviate. You guys should not observe your mobile. You should observe and focus here. Okay. Now what I'm going to do, I'm going to create an object of masala dosa like this. I'm going to prepare masala dosa now. Observe. In between, I'll ask you questions. Okay. First of all, is it possible? Hmm. Perfectly possible. Correct. Now, what about this one? Is this possible? Now, what is the type of MD here? What's the data type of MD? Dosa. Try to understand it. So this is called the reference. Okay. Your reference is of, this is called the reference. Okay. The reference is from superclass. This is a superclass reference. This is called superclass reference. And the right side, we do have an object, and the object is from subclass. Subclass object. The object is from subclass and the reference is from superclass, and this pretty super cute concept is called as what? Upcasting. It's called as upcasting. Are you clear now? Good. Now let me try to assign. Now please observe what's the type of MD. The type of MD is dosa. Okay, the type of MD is dosa. Now let's apply now casting here. So it is like the bigger data type. This is a smaller data type. You can just say this is like byte. This is like byte. Nothing but, let's say, the data called 10. Think it like a super that is nothing but an integer. Nothing but, let's say, okay, this is an integer. Okay, this is a byte and this is an integer. So the data is called 10. Okay, forget about the even the data also. Let's not even worry about the data. So the data type is here a byte, example, smaller data type. This is a bigger data type, correct? Masala dosa is a smaller data type. Dosa is the bigger data type. Now, can I assign byte back to byte reference? That's what we have seen in the previous example. You can assign, right, the byte back to the byte, right? You can assign this I back to byte. That's called lower data type. In the same way here, I'm going to apply the same concept here. Now what I'm going to do here is the data type of MD is dosa, which is higher data type. The data type of masala dosa is the lower data type. Okay. Now what do? I apply now casting. If I assign this into masala dosa, okay, I call it as only D. Okay. Masala dosa MD equal to D. Observe data type of D is the bigger data type. This is bigger data type. So now the data type of MD is masala dosa, which is smaller data type. This is smaller data type. I'm assigning it to the bigger data, the smaller data type. Data type of D is bigger, that is dosa. Data type of MD is smaller, that is masala dosa. Is it possible? I expect the answer from you guys in the chat window. Why no? Why no? Most of you are, yes, compilation error. No, not possible. Most of you are answering 100% correct answer. Why? What is the reason of it? The reason is pretty simple. We all know the rules of the compilation. So what are the rules of the compilation? The rules of the compilation says that the left side data type should be greater than or equal to the right side data type, rule number one, or if the left side data type is smaller than, if your left side data type is smaller than the right side data type, then you should apply for casting, right? This is the rule. So observe, the data type of D is dosa, which is bigger. Data type of MD is masala dosa, which is smaller. Hence, here you're going to get compilation error. Compilation error. This is not possible. Okay. So now what's the right answer then? The right answer is this. Masala dosa MD equal to, I should apply this casting. Never forget to apply this casting. Okay, this is something very, very important here. Okay, this casting is very important. Try to understand it. So the data type of D is dosa, which is bigger. So apply the second rule. Observe rule number two. Rule number two, if left side is smaller than the right side, you should apply casting. If smaller, this is FMD is smaller, D is bigger, hence I'm applying this casting. So this perfectly works, and this concept is called as down casting. Down casting. It's called as down casting. How? Observe here. Okay, so the data type of, let's say D, what is the data type of D? The data type of D is dosa, which is bigger data type. Okay, that is there on the right side. The left side, you're assigning it into MD. What is the data type of MD? Masala dosa. Masala dosa is same as dosa. Certainly no. Masala dosa is smaller to the dosa, hence it is smaller. Okay, and observe, this is diminishing. This is a kind of narrowing, but this narrowing concept is technically, here we don't call it as narrowing, here we call it as downcasting, because D data type is dosa, right? And then MD data type is masala dosa, which is smaller one, right? So dosa is higher to the masala dosa, or dosa is higher to the masala dosa, right? So that is dosa is the bigger or the super class, and the subclass is called as what? Masala dosa. It means to say masala dosa is downside. Observe, masala dosa is down. It's like down, it's coming down. So that's why we call it as downcasting. Why the word casting? Casting means conversion. I'm converting data of the dosa to masala dosa. That's why this is called as what? Casting. This is called as casting. Why downcasting? Because you're casting from dosa to masala dosa. You're casting from dosa to masala dosa. That's why it's called downcasting. Clear with this? You can ask me questions. Both are same, Rahul. Rahul is asking me a question. What's the difference between narrowing and downcasting? It's almost same, but they're just like it's like this. Okay. In one context of primitive, we call it as narrowing. From the context of non-primitive, we call it as downcasting. That's it. But functionally, both are same. Any other questions? Yes, Deepshika is asking question. First, we perform upcasting, then downcasting. Yes, without upcasting, you cannot downcast. Without upcasting, downcasting is not possible. I'll repeat, without upcasting, downcasting is not possible. Shivam, I answered. Always. Yes, Deepshika, always. See, it is like this, okay? Before the start, you cannot end. You're talking about end means somewhere it should have started. It's just like that. AP is asking question that, sir, in narrowing, we were knowing that left side variable will hold, but what in case of downcasting? Yes. Okay, there is one trick here. I'll teach you the trick, okay? How do I know that, sir? I teach you one trick here. Aditya Kumar is asking, what is the definition of downcasting? Aditya, it's little tricky to define what is downcasting, but I will try defining downcasting. I'll give you my own definition for downcasting, but let me give you two more examples so that you become more confident on downcasting. Then I will give you the definition of downcasting, okay? I will also answer this guy. Who is this? AP was asking me a question. Yes, there is a trick for that AP. I'll teach you that trick in today's session. Next, Rohan Thakur is asking, downcasting me, bracket me, super class का नाम. ए रोहन, ये क्या है यार, ऐसा कॉम्प्लेक्स क्वेश्चन लिख रहा है तुम. डाउनकास्टिंग मी ब्रैकेट मी सुपर क्लास का नेम लिखना जरूरी है. I didn't understand. See, Thakur, I'm not able to, I'm not even like, I'm not even suppressing you. Don't think in this way, but थोड़ा मुझे तुम्हारा क्वेश्चन समझ में थोड़ा दिक्कत आ रहा है. Okay. Prem Krishna Mishra is asking, sir, how it is not possible? We can directly create an object of higher data type and cast it into lower data type. There is a problem, Prem Kishan, there. I'll explain you that problem. That's why I said you have to, understand it. You have to understand this with a little more examples, okay? Okay, fine. Now what I'm going to do, I'm not going to answer your question right now because there are 5, 6 students are asking the question. Okay, Deepshika, hold on, Deepshika. No, you are wrong. You cannot write like that. You have to casting means that bracket is required. Where is the bracket in your case? Deepshika is wrong. You need to write that bracket. In casting, bracket is required. So hold on, hold on, hold on. Now observe. I'll give you two more example and I'll teach you there is one failure scenario here. There is a scenario in which your program fails. Okay. I'll explain you all those things, but before that, let me give you one more example so that you get confidence on it. Okay. Now hold on. Just observe. So let me start explaining this with one more example. I have a class, a super class. A superclass called fruit and a subclass called mango. A simple example, okay? So, of course, it's an extends. So fruit is the bigger data type, bigger type, bigger type. And here it's a smaller type. Right? So now observe. I write a code for upcasting because I said that without upcasting, downcasting is not possible. Okay. Now I write a code like this. Fruit f equal to new mango. So we call it as upcasting. Try to understand it. We call it as upcasting, right? Because the object is from subclass, the reference is from superclass. So if someone asks you, what's the data type of F? What's the data type of f? The data type of f is fruit. All right. So now the rule says that if you want to assign it into lower type, what is the fruit is a higher type, the mango is the lower type. If you want to assign it into lower type, you have to write the program like this. So mango m equal to, you have to apply this casting. That bracket is important, Deepshika, because every time she used to forget to write that. Mango, this is casting, okay? Of casting means this bracket is required, okay? Of f. So now observe, left side data type is f, sorry, right side data type is f. F, what is a variable, right side variable is f, left side variable is m. Okay, what is the data type of f? Fruit. Fruit is bigger or smaller? So bigger. Okay, now what is the data type of m? Left side is m. What is the data type of m? Data type of m is mango. Mango is smaller data type or bigger data type? Mango is smaller data type. So it means to say you are stepping down. That's why it is called as downcasting. All right, this is called downcasting. So there Aditya Kumar is also asking the question, sir, in case of primitive, I was knowing what is the capacity, like 4 bytes, 8 bytes, 2 bytes and all. So that's why there was not an issue. So here, how do I know that, right? It's very easy. You have to apply one trick here, and I call the trick as Z trick, okay? What do I call that trick as? Z trick. Remember this Z trick. Sir, what is that Z trick, sir? Here and here must be same. This is the trick, okay? This is called Z trick. So it starts from, this is one assignment, one variable assignment. This is one variable assignment. In between, whenever you cast, you just have to, this Z technique you have to apply. So whereas this one and this one must be same. Let us apply that Z trick here. Z trick here. Let's say I start from here. I start from here, and then it goes here, and then it goes here. Okay, now observe, I started from here, first point. I went from here till here, this is the second point. From then I came here, this is the third point. From here I go here, it's the fourth point, right? So now extremely important concept is this one and this one must be same. Now observe, it's an object of mango. Here I'm assigning it into mango, perfectly possible. If you observe these two, observe this, okay? Mango M, observe here, this is called 1, this is called 1, and this is called 2. If you observe 1 and if you combine 1 and 2, 1 is mango M, 1 is called mango M equal to, what is there on the right side? You're assigning F. What is the meaning of F? New mango. So this is called 1, this is called 2, right? Observe mango M. What has been assigned to mango M? F, right? F means what? Ultimately, F is pointing or referring to what? Mango object. Right side is object of mango. So it means to say this is an object of mango object. Now, can I say mango M equal to new mango? Perfectly possible. This is a trick. This and this should match. What if it does not match? What if it does not match? All right, that's now the next scenario. What if it does not match? What happens? Yes, Aditya Jain, correct. Aditya Jain is asking, so we can say that in typecasting both the type must be same. Yes, Aditya, it must be same. Prem Kumar Mishra is telling, in this case, what if I write fruit f equal to new fruit? Things will fail. That is what the failure scenario, which you are going to understand right now. Okay. Okay. Just observe. Let's understand this failure scenario now. Everyone try to understand. I'll write the program for failure scenario. Now I write one superclass with two subclasses. Okay. The superclass is called vegetable, which has two subclasses. Potato. So carrot extends potato. This also extends potato. Sorry, vegetable. Sorry. Carrot extends vegetable. Potato extends vegetable. So vegetable is the superclass, nothing but a bigger type. Carrot and potato are the smaller type. Please understand there is no relationship between carrot and potato. Probably they are siblings. They are the children for the same parents. Okay. So here there is a relationship between carrot and vegetable. What is that relationship? Is called as is a relationship. This is also called as is a relationship. Is a relationship. So between potato and vegetable is a relationship. Potato is a vegetable. Carrot is a vegetable, right? That's the nothing but subclass. So, but between carrot and potato, there is no relationship. Remember this. Between these two, no relationship. No relationship. No relationship. You all have to understand one thing very, very clear. So in upcasting or downcasting, the inheritance relationship is important. I will repeat, in upcasting or in downcasting, the inheritance relationship is important. The superclass subclass relationship is important, right? Without that, you cannot apply casting. So you cannot upcast, downcast between carrot and potato. You can upcast and downcast between carrot and vegetable and between potato and vegetable, but not between carrot and potato. So this is extremely important. Don't forget it, okay? Now observe, I'm going to write some code. So I write a code for upcasting. New carrot. Simply tell me object is from which class? In the memory, object is from which class? The object is from carrot class, correct? So here, so the object is from which class? The object is from carrot class. Now, what's the data type of V? The data type of V is vegetable. Vegetable is superclass or subclass? It's a superclass. Hence, the object is from carrot class, but the reference is from superclass. Okay. So this is called as, upcasting, right? Now I'm going to write the code for downcasting. Try to understand it, okay? I'll just change the color, guys. I like this color, let's say this one. So what I'm going to do now, what is correct here? Correct is this. When I say caret ct equal to caret of v, this is perfectly possible because right side data type is v. So right side variable is v, left side variable is ct. This is called variable assignment. Okay, and also this is called typecasting because the right side data type is vegetable, data type of v is vegetable, data type of ct is caret. So they are not same, they are different, hence it is called typecasting. And data type is non-primitive, hence it is called non-primitive casting. And of course, right, whenever as per the rules, what are the rules that we know now? The rules is that if left side is by chance smaller than right side, then we should apply for casting, right? Deepshika, observe, bracket is important. Okay, when the left side is smaller than right side, we should go for this type of casting. So I'm applying the casting here. Observe, I'm applying the casting. The data type of v is vegetable, which is bigger one, and the data type of ct is smaller one. Okay, so this is called vegetable, bigger one. All right, left side is ct, nothing but caret, smaller one. Caret is smaller one, hence you should step down to this. It's called as downcasting because, like, assignment works from right to left. That's why I have written this. This is called downcasting. Clear? Downcasting. So hopefully you understood this. And if you apply this Z technique, the one which I said, right? Just apply that, Z technique. Z technique, you can just say this. Now observe, if I apply this Z technique, zig, zig, zig. So here, the object is from which class? Caret class. That's nothing but your caret object. Can I assign caret object to caret reference? Perfectly correct. You can assign caret object to caret reference. If you assign caret object to caret reference, the program looks like this. Caret reference ct equal to caret object, new caret. This is perfectly correct. It means to say your reference is from caret, object is from caret. That's realistic scenario and it works. It really works. Are you clear now? It really, really works. But the same program, by chance, okay? Hold on. Just gonna erase this. Right? If the same program, if I try to write the program like this, I'll go with the rule. What is that rule says? The rule says that left side should be, if left side is smaller than right side, you should apply casting. Okay, very nice. I will just go with the compiler rule. I just write the program like this. Potato P equal to potato of V. Observe this program. Syntactically, it is correct. What is the data type of V? Data type of V is bigger one, nothing but vegetable. Right? What is the data type of P? Smaller one, that is nothing but potato. This is smaller one. Okay, when right side is smaller than left side, what do you need to do? You need to step down, and that's what I have applied for casting. This is programmatically correct. Works. This is right side, this is left side. It works. So it means to say, carefully observe, this line of code is syntactically correct. This line of code is syntactically correct. So no compilation error because we are following the rule. The rule says this, and my program is very realistic. But logically speaking, there is some issue here. What is the logical issue? The logical issue is this. The object is from caret. Can you v observe now? You're casting v to p. Nothing but v is, though I agree it's a vegetable reference, but it is referring to which object ultimately? V is referring to an object of caret. So v is nothing but a kind of caret object. Can you assign caret object to potato? Is this practically possible? Definitely no. Hence, it will not give you any compilation error, but it gives you runtime error. You get this runtime error. Never forget this. You get runtime error. This runtime error is technically called as exception. If someone asks what is exception, you must say that exception is nothing but runtime error. So a runtime error, nothing but exception called as class cast exception, class cast exception. In simple, we call it as CCE, class cast exception. All right, that is the right side data type is superclass, the left side data type is subclass, right? You're casting. So while casting, you get an exception, nothing but runtime exception, runtime error, while wrong casting. While, see, observe there are three words here. Class is one word, cast is another word, the exception is another word. Okay, class cast exception is one word. Never forget this. This is one word. Okay, we simply call it as CCE. So exception means runtime error. So it's a runtime error, of course, which occurs at runtime. Why it occurs at runtime? Because you are wrong casting, and that casting is happening with respect to classes. You are casting caret to potato, which is not possible. That's what I asked you to apply this kind of Z technique now. So I'm going to apply this Z technique here. I'm going to apply this Z technique here. Please observe vegetable caret, vegetable v equal to new caret has been assigned to this. Now apply. The object is from caret, but the reference is from potato, which is not matching. This is not matching with this. That is the reason we are going to get class cast exception. We simply call it as CCA, which is runtime error. Now if you apply this, Aditya, I think was Aditya, I forgot his name. I think Aditya, he was asking me a question. So vegetable V equal to new vegetable, then I'm going to, downcast it. Aditya, if vegetable V equal to new vegetable, it is not called as upcasting only, but still you can downcast it, but that becomes illogical. Here it will fail. Okay, so I hope now this has given a better idea to you guys. So I think now your question really makes sense. Now, as per this latest understanding, now you should revisit your questions. I hope some students who had already asked the question, they had already got the answer through this example. Still, if you, I don't mind giving one more example, and I will give you one more example. But before that, just wanted to take your opinion. Yeah, downcasting is permitted without any compilation error, Ram. In downcasting also, sometimes we don't get compilation error, but at runtime we get an error. Yes. Yes, Savani. Mukul Sharma. Yes, so yesterday you were told one object is multiple refer. One object can have multiple references. Then how they show runtime error? No. Reference is just a variable which is storing an object identity. So any variable can store an object identity provided if data type matches. Yes, Akash Chatterjee, correct. You're correct. Vegetable V equal to new potato, then you can downcast it into potato. Perfectly correct, Akash. Yes, Intel, you're also correct. Yes, perfectly correct, Intel. So observe Intel question is something like this. Intel, I don't know what is his real name. It is showing Intel. So his program is something like this. Sorry, it's like this. Okay. So then potato p equal to potato of v. This is perfectly correct because if I apply this technique here, observe here this object is potato, reference is potato, right? This is super type, super type, potato is super type, sorry, v is super type, p is potato subclass, smaller type, hence it is called downcasting, right? This works, perfect. No, Aditya, not possible. I understood your question, Aditya. That's not possible. Why? Because you are see, ultimately, okay, fine. Aditya is asking question. Okay, I think everyone are able to see in the chat box his question. Now observe. I give you Aditya one scenario. You should tell me why it is not possible. Okay, I have a reverse question for you. Carefully observe, Aditya. Aditya, tell me, is it possible? Observe this thoroughly. This is syntactically correct, hence no compilation error. So at runtime, you lose the data. Runtime, we lose the data. Why do we lose the data? Because 1024 is the data that cannot be stored in byte. The byte capacity is minus 128 to plus 127. If any data more than this, it cannot be stored. Correct, no, Aditya? Okay. Similarly, in this case, when you say vegetable, v equal to a new vegetable, observe technically what is this object of vegetable. First of all, we should not create an object of superclass, Aditya. First of all, again, you will ask me, sir, why, sir? This is something new for you guys. Ideally or technically, we must not create an object of superclass. Why? I will explain you later stage, not now. Again, now don't ask me, why should we not create an object of superclass? Okay. Ideally, we should not create an object of superclass. But since you don't know, you created it. Now, object is from which class? Vegetable class. So now if you assign this like this, potato p equal to potato of v. This code technically becomes like this. Technically it is like this. What is a v? V is a superclass reference referring to new vegetable object. Object is from vegetable. It looks like this. The first part is this, which is assigned to v. V is referring to the second part. Now you take the first part. potato P equal to second part new vegetable. Is it possible, Aditya? Reference is from subclass, object is from superclass. This concept is not possible. If the reference is from superclass and the object is from subclass, then it is possible. It is just like this. Okay, your dad friend has come to your home and he has invited for a function, one big function, a marriage function or some reception function. If your father is busy, then he will say, Aditya, you please go and attend that function because I'm quite busy. When your father is expected, instead of your father, you can go and attend, participate. That is possible. That is nothing but, right? In vegetable, V equal to new vegetable. Who is expected? Vegetable. Instead of that, the son can go. Possible. Then it is called as upcasting. Possible. Now think about the reverse scenario. Your friend has called you for a party or for some function. If you are busy, can you send your father to that? Hey, dad, please go and attend that function party because I am quite busy today. That's not possible. So that is what happening here. That's not possible. So this must match with this. Simply you cannot assign one to other just because of compilation rule. That's why I say compiler is guldo. Compiler does not have smartness. Compiler goes with the predefined instruction. Okay, but logically you should think whether it is practically or logically possible or not. Hope now Aditya has understood. Sure, thank you. Prem Kishan, again hold on. Today's session, yesterday's session, I said I'm not going to teach you right now of what is the use of upcasting, downcasting. Okay, now obviously you have that question like, why it is required. I can directly write potato P equal to new potato. Why the hell I should do like this? Yeah, Deepshika, I'll give you one more example. No problem, I'll give you one more example before the end of the session. I'm going to give you one more example, don't worry. Yes, Prem Kishan, it is same. That's the reason. Then obviously when both are same, a question arises to you. A question, okay, fine. Okay. For others, I'll explain what is the I'll explain what is Prem Kishan question. Vegetable V equal to new potato, and then finally potato P equal to shit. Potato P equal to what is happening here? I don't know. Sometimes it has a problem. Potato of V. So this code is equivalent to these two codes are same. These two codes are same. Obviously, it leads to a question. Then this is easy than this. Why the hell I need to go for the first option when compared to second option? Well, that's what in tomorrow's discussion, not today. Tomorrow we're going to understand in what scenario we use it. Don't worry about it. So the entire example, entire upcasting, downcasting, I'll give you one more last example. Okay, very simple last example. Now everyone should focus. Simply focus. Okay. I select one good pen this time. Oh, what example? Can we take an example of bird? Okay, bird has two classes. Okay, two subclasses. One is called crow. Okay, you're not happy with the crow. Crow is a bird. Okay, I have my favorite bird called, oh, what is that? Hornbill. This is my favorite bird. I think everyone knows what is hornbill here. This fellow is called hornbill. This is called hornbill. In my hometown, near to my farmland, we have a lot of hornbills. I love this from my childhood days. Yes. Anyhow, coming back to the concept, this is an inheritance hierarchy. Okay. So there are two ways of writing this: upcasting and downcasting, and also I'll write the failure scenario. Okay. The first one is okay. I just write the upcasting code like this: per b equal to new hornbill. This is called upcasting, right? Now, what is the right downcasting? Hornbill, hornbill, HB, H, oh, not HB, it has become BB. HB, hornbill equal to hornbill of B. Yes, perfectly possible, right? This code is almost equivalent to hornbill HB equal to, you're assigning B. B is a bird variable, but object is from hornbill. That's why hornbill HB equal to almost new hornbill. So if you apply the Z technique here, it works perfectly, right? This is matching with this. These two are matching, hence perfectly it works. So you can also cast it in a wrong way here, in just this way, which is your program may be syntactically correct, but logically it is wrong. For example, crow C equal to crow of crow of B. Observe, syntactically correct. What is the syntax? If right side bigger data type is casted to the smaller data type, you should use this kind of casting. It works, but syntactically it works. So hence, I just write somewhere here, no compilation error, no compilation error. But at runtime, you're going to get class cast exception. CC, class cast exception, because B is ultimately a bird reference, no doubt about it, but it is referring to what object? Object is important. Object is from which class? Object is from hornbill. How can you convert hornbill to crow? It becomes crow C equal to new hornbill. That's not. This line of code is something equivalent to new hornbill, like this. Crow of, what is B? B is referring to new hornbill. So it's like this new hornbill. So it means to say your code is looking something like this: crow C equal to crow, that is casting, to what is the meaning of B? New hornbill. So new hornbill. I mean, this is meaningless code, yeah. So you're creating an object of hornbill and doing some magic and converting it. Converting means casting it into crow. You're trying to make hornbill to crow, which is not possible. Hence, you get here beautifully, okay, class cast exception. This is 100% wrong. So no compilation error, but at runtime, you're going to get an exception. All right. Yes, anonymous. Deepshika, we don't lose the data in non-primitive, but we get class cast exception. Yes, Ram. For downcasting, upcasting is compulsory. Without upcasting, there is no downcasting. That's what I'm trying to say. Without start, there is nothing called end. So without upcasting, there is nothing called downcasting. Yeah, I think that's it for today. So I explained you what is upcasting and what is downcasting, what are the possibilities, that is down class cast exception and other things, right? So what is the use? That's in tomorrow's class. Okay. Thank you for participation. Have a good day.